Thanks a lot for coming. I worked at Microsoft for 8 years, and for the first 4 years when I worked at Microsoft, I was a lot like the rest of the Microsoft employees back in those days, where I worked on developing new features for our software, but I didn't really know a lot about engineering security into those features. So 4 years ago, something changed. The first thing that changed is that Microsoft, Bill Gates, and everyone else decided that Microsoft was going to try to do security. And you've seen evidence of that today through a series of talks, and I appreciate you coming to mine. And the second thing is that my brother discovered that he could download music for free on the internet, which meant that over the last 4 years I've been cleaning up the systems around the family house. And I'm sure that a lot of folks can relate to that experience as well. So based on those first 4 years and the second 4 years and the changes therein, that's kind of a framework that we're going to use to talk about security at Microsoft today. We're going to talk about a mock attack. Think of it as a crime scene recreation of an attack that might have taken place before Windows XP SP2, kind of before some of the SDL practices that we've designed. And then we're going to look at how the SDL has changed the way that Microsoft thinks about security and the way that we engineer our products. And we'll look at the specific changes that that's evoked, specifically in IE7 we're going to focus on. There's a meta theme that I want you to pick up on in terms of the changes that we've implemented for IE7. We've made changes that help protect the system, that help the system be more robust against attack. And we're also making changes that help the end user make better decisions about the things that they do on the web. So it's worth starting, again, from back in the old days of Microsoft. And I worked on the IE6 team. And I was the program manager for a feature called the media bar, amongst others. But the media bar allowed you to play music directly inside of the browser. And in addition to that, we made it scriptable so that a website could target content at the media bar and get some information about the content that, what state was the song in terms of how it was playing. And I remember one of the first memories for me with security was, as we were designing and building that feature, I thought, hey, is it possible that maybe a website could get some information about the media that you're listening to, but it's not the website that started that media in the first place? And maybe it's some content that you don't want that website to know about. And I didn't even understand that that was really a security bug, but I knew there was something wrong there. And I remember that in the old Microsoft, it was difficult for us to go and have a conversation about fixing that type of a bug and explain why it was important to put security first. As a result, when we shipped that feature, we were able to fix that bug, but there were some other bugs that came out that were security bugs that we might have picked up on had we been focused on security development from the beginning. So really what we're going to do now is I'm going to go look at, again, a crime scene recreation. Here I've got IE6, and I'm going to try and recreate something like that media bar attack. Now, nothing I'm going to show you here in terms of these attacks is real and something that an attacker could do today, but it's interesting because it kind of demonstrates some of the theories and attacks that people used to use. So here, this page is on myevilmyspace.com, and what it's done is it's created an iframe through to a local resource. That local resource is on my local machine. IE6, before XPSP2, had elevated privilege for HTML that was running inside of the local machine. So if myevilmyspace.com could inject some HTML into that local resource, well, myevilmyspace.com could do some bad things on my system. Well, here I can see that IE threw a script error, and what happened is that myevilmyspace.com's domain name didn't match the domain name of the local resource, and therefore that failed. This is an illustration of the cross-domain security boundary in IE that's always been there. But so this part of my demo didn't work. But historically, in previous versions of IE, there were holes in that boundary. For example, imagine that in that domain name, I encoded special characters, and I used percent signs to try and encode the actual same path of my local machine into the address bar. And you can imagine that IE might make a parsing error and mistake the URL that's in the address bar for the local system. And then that script injection might be successful. So I can't pull that off today, but what I'll do is I'll go over to another local resource, Now here, it's the exact same file. I've just navigated to it directly on my IIS system. But now it's going to be able to go ahead and inject that into the local resource. Okay, so something bad happened. Who knows what's going on here? Windows Defender's coming up. Something really nasty happened. Let's see what's going on. I go over to my startup folder. Uh-oh. Okay. So what happened is I was able to inject some script that accessed an object that was unsafe for use, and then use that object to download and ram evil.exe into the user startup folder. So the next time the end user boots up their system, evil.exe is going to run on this system. Now, again, this is a crime scene recreation. I had to go find an old vulnerable object that's been patched for years. I had to uninstall the patch. I had to disable virus scanners. You know, Windows Defender doesn't like me doing this demo in front of you and comes up and complains. But you can see there were a couple of things going on here. So let's go back and look at some of the things that were elements of that attack. I talked about the possibility of a URL parsing error and how that was maybe one of the first steps to the attack. And then I also talked about the need to be able to inject script across domains. And finally, we talked about how that HTML that was running that local resource was going to need to run with higher privileges and have access to objects that aren't marked safe for scripting. So this is Microsoft circa 2001, prior to the security development lifecycle. Things like this, attacks like this could have happened. And as a result, when Microsoft started trying to build security into the product, we came up with the security development lifecycle that you've heard a lot about today. And I don't want to go into excruciating detail on this slide that you've already seen before. But there are a couple of really important changes. Instead of simply designing a product and not thinking about security into the end, you can see here on this slide, we think about security and designing for security up front now. And that's an important change. Also important, when the security research community finds a vulnerability, we have an organization of people that specifically spend time listening to them and working with them. And then, instead of just kind of ignoring security as a low priority, now we actually take those vulnerabilities that people report and we use them to design and come up with new ideas about how to make more secure products. So that's kind of the way that we'll focus our discussion today. And I'm going to drill in on one of the particular tools for the security development lifecycle, and that's called threat modeling. That's the tool that we use for secure design. If I talk about the red team and the blue team, does anybody know what I'm talking about? So when I talk about the red team and the blue team, imagine the red team is the attack team, the guys looking for vulnerabilities in your system, looking for ways to break in, and the blue team is the team trying to defend the system. So when I look at this diagram on the screen that's probably faded out for you, what I see is a set of resources that are going to come under attack and a set of avenues to approach them. That means that is the playing field between the red team and the blue team. The red team is, maybe at badguys.com and going to send malicious URLs that have those encoded characters, HTML that's got garbled input, and using those vectors. That's the way that the red team's going to attack. So this is a super high level look at how a threat model might be used to identify attack vectors inside of a product. This is super high level. With IE, the only thing you could determine from this is, geez, the internet looks scary. So obviously this isn't useful for making IE or another browser safer. So really quickly, I want to show you how Internet Explorer works kind of at a component level, and then we'll tear apart one of these components to look at the threats that we saw in that mock attack. When a user types in, myspace.com into the address bar, that goes into the user interface layer, sends a request through the network requests layer, which returns a bunch of HTML and script, and then we render that in a page, and maybe we have some Flash content or some other script content that we load as well. So those are kind of the three main steps to going to the internet, bringing back a web page, and showing it to an end user. So now, when I showed you that attack, we saw there were a couple of places that we had to be compromised. There were 3 places we had to be compromised. Now let's look at this data flow diagram. This is a drill down into the page rendering layer. Let's look at the avenues of attack that had to be compromised in order for that attack to be successful. So the first thing is that we saw that maybe there was a URL parsing error. I described that through some encoding, the attacker might convince IE that this wasn't my evil myspace.com, that it was really, c:/inetpub root. So now that's a threat. That's a risk that we would want to mitigate. Okay. The other thing is that once that trick had happened, that the script was able to come back and access a page that it shouldn't have had access to. It was able to access a local resource page. And then finally, the victim page was able to run with elevated privileges and access to an object that it shouldn't have had access to, an object that was capable of writing that evil.exe file to the file system. So now let's go back and I should be clear on this diagram. I've pointed out ActiveX as the threat, and we'll talk more about ActiveX later. But in the mock attack that I used, the object that I had used in that case was not a normal ActiveX control. It was a kind of a deeper level COM object that I used in the attack in order to write that file system object. But it's a similar threat. So now that we've seen those threats, with using the security development lifecycle, we were able in XPSP2 in particular to go back and engineer protections against that. So that web page running with elevated privileges that was able to access an unsafe object, that's all been locked down by the local machines on lockdown in XPSP2. And we've added a bunch of code quality improvements. So specifically, a lot of those URL parsing errors that we'd seen before went away. But that wasn't a big focus in XPSP2 compared to IE7. And then we did a lot of other things that were more prevalent to the user. So you may have seen the information bar before you download an ActiveX control or before you allow a pop-up from a particular website. And those are the things that most people are more familiar with about XPSP2. Very important changes that help protect the user and put the user in more control of their system. But those didn't necessarily fall out of these threat modeling exercises. So while we were busy with XPSP2, this thing called phishing came along. And I stole this slide from the anti-phishing working group from Peter Cassidy. He left it on my system. That'll show everyone in this audience about leaving slides on my system. I'll just use them. But it's really easy to see here that phishing is still growing. Phishing is on the rise. In particular, we know that malware is now being used to harvest end users' information and pass that along to the criminals. So it's important that we continue to invest in security. And I think that everybody in this audience, I'm not going to be saying anything controversial by saying that security is never over. Security is a journey, and it's something that we have to be committed to as an industry in order to kind of to help protect end users. So now let's go back to that threat model diagram. And we talked about some of the threats before. And we've talked about the security development lifecycle. There are a couple of principles that are pretty obvious to secure design. One of them is to reduce the attack surface of the product. So if I can reduce the number of components that are running in a system, I can reduce the complexity and therefore reduce the chance for a vulnerability potentially. So one of the examples of attack surface reduction is a feature called ActiveX opt-in. I don't see HD Moore here in this room today, but HD Moore has ran a project called Browser Fun, the month of browser bugs, and he was able to go ahead and find vulnerabilities in some ActiveX controls that were sitting around the system.